In the last video, we learned that a sensor or receptor receives information from a stimulus and sends that information to a control center, which is your brain and spinal cord. If that stimulus is out of the normal range, your control center will then activate an effector, muscle or glands, in order to normalize the stimulus back to normal range. So let's look at a real-life example. The stimulus could be temperature. In this case, it exceeds normal body temperature. So that information is sensed by this receptor, which is a thermoreceptor, which happens to be nerve cells in the skin and in the brain. Your receptor will then send that information to your control center. For temperature, there's a regulatory center in the brain, and since it found that it is outside of normal range, it will activate an effector, a muscle or gland, in this case sweat glands, so you perspire and your body temperature reduces. So what we have looked at is called negative feedback. Negative feedback takes something out of balance in your body and returns it to a balance. The receptor picks up some type of change, sends it to a control center. This is the British spelling of center. The control center will activate an effector, which makes the change by creating a balance in the body. So I'm going to explain negative feedback a little better on the next slide. Although it doesn't say it here, let's use temperature as the condition being controlled. So this lower limit and this upper limit, this is the normal range for temperature in our body, meaning anything within that range is fine. If we get over this limit, well, then your temperature would be too high. That would be a fever, right? If we go under this limit, then your temperature would be too low. That could be hypothermia. So what happens when your temperature starts to rise? Well, negative feedback brings it back down to normal through its receptors and control center and effectors. Sweating in our example here for body temperature. What happens if our temperature gets too low? Well, negative feedback will return it back to this regulation point. In this case, it'll activate muscles. Shivering would be, muscles would be the effectors for shivering. So you can see negative feedback returns the condition back to that regulation point, whether it's too high and it brings it back down, or whether it's too low and it brings it back up. The key for negative feedback is you're changing direction to get back to this regulation point, whether from above or from below. Homeostasis in our body is maintained through negative feedback almost all the time. Positive feedback is usually something bad, because what positive feedback means is if something's getting too high, if that's positive, meaning your body likes it and wants more of the same and it keeps rising. You can see how that would be a problem. If something's getting too low, positive feedback continues in that direction, and you can see how that would be a problem. Imagine blood sugar, positive feedback. Once your blood sugar rises, it would just keep rising. That would be diabetes. What happens if blood sugar gets too low and keeps going low because of positive feedback? Well, that would be hypoglycemia. So positive feedback is usually a disease process. Negative feedback is what allows these conditions to change direction, to return to the set point. I explained positive feedback on the previous slide, but here's the text. Positive feedback involves more of the same. If something's rising, it'll keep rising. If something's falling, it'll keep falling. Usually this is not a good thing. It's a disease process. However, there are two examples of normal positive feedback in our body. One example of normal positive feedback in our bodies is labor or childbirth. And you can run through this, but the result is contractions keep getting stronger. And that's positive feedback because things are increasing and they keep increasing throughout the process. Blood clotting is our second example of good positive feedback. If we injure a blood vessel and are bleeding, platelets rush to the area and they send chemicals to recruit more platelets. Of course, if we're bleeding, we want this flow of blood out of the body or out of the vessel to stop in a hurry. So more platelets that get there, more signals that go out, which means more platelets arrive. So platelets keep on increasing in number. That's positive feedback, but that's for a good reason, and that's to stop the bleeding.